Hi guys, let's look at the homework from the first part of 8.3. Today we did the other part, but one thing that I did not really do in the previous lecture, but I talked a bit about it in today's lecture, is how we can solve this by hand. And so this was one of the homework problems, number 8. I hope you were able to do that, otherwise now you see it again. Or you can try it now that you heard me do it in the lecture. So we had number 8, we had a divide and conquer recurrence relation of this nature, plus 3. And the question was, let's do number 8D. Now I'm fooling, let's do number D, sorry, C here. Because I cannot just do 8C. Actually, when I do this, I will solve A and B as well. I'm not going to do D. D is even more work, but let's just do it. So what you have to do? Well, we need to calculate f of 64, right? And the only way at the moment we have is, and in fact, unless you look at the theorem that the book gives, but the way we have to do it is by hand, is just start plugging in. That is twice f of 64 divided by 2 is 32 plus 3. And then what is f32? That is twice f16 plus 3. Now you say, oh, it's going to take for a long time, 64 is such a big number. No, look at it. It's going to go down quite quickly. And then f of 8 is twice f of 4 plus 3. And f of 4 is twice f of 2 plus 3. And f of 2 is equal to twice f of 1 plus 3. And we know that f of 1, and this is typical, of course, always, we need to know how recursion starts. And f of 1 here was supposed to be 5, they told us. Okay? And then it's just a matter of now we work, so this is going downwards, and now we go upwards again, right? So we go around, and then we go up again. By start plugging in the number. So we plug in this number. I'll do this in different color now. So this number I'm going to plug in here, and I'll find this is 2 times 5 plus 3, that is 13. And then this number goes in here, because it is f of 2, that is 2 times 13 plus 3, that's 26 is 29. Plug this in here, we get 2 times 29, that is 58, plus 3, that is 61. Plug that in here. 2 times 61 is 122, plus 3, that is 125. Plug that in here. That is 250 plus 3, that's 253. Plug that in here. And then finally we see that is 506 plus 3 is in 509 steps. So that's really what it was. It's nothing deep there, and we have seen that we can do this by hand, especially of course if the number is small. But that doesn't tell us anything about the complexity yet, so that's why we needed today's lecture. It tells us about the complexity. And then the other one I wanted you to do was number 14. So 14 was asking, actually kind of developing a divide and conquer. I hope it was not too hard. So we have n teams, and n was a power of 2, but let's not bother ourselves by this extra 2 to the k. N is it n teams, okay? And what is the determinant? Well, we divide these n teams in 2 groups of n over 2. No, I'm saying, sorry. No, I'm saying it wrong, right? I'm saying it completely wrong, sorry. So these n teams, we will break them up in groups of 2. Sorry, we break groups of 2. So we have 2, 2, 2, 2, 2. And how many groups of 2 we have? N over 2. And each of these will play against each other. And there will be a winner. So there's going to be one winner here, one winner there, one winner there, one winner there, up there. So in total, we're going to have a tournament of these remaining n over 2. Okay, so let's, f of n is the number of games in a tournament of 2 to the n teams. Well, what we do is we divide the team. We're gonna go to a tournament of This is where the divide part comes. We're gonna make a new tournament of half the size. So we have this one tournament and the new tournament of half the size. And what tournament is it? It's the tournament of the winners of the n/2 games that we had over there. Okay? So we only gonna do this tournament once. So the coefficient in front here is 1. So from today we also discussed this more generally, and divide and conquer has three parameters, right? It always looks something like this. And then we have a function here that, let me see, what's the word? Plus a function here that could be a more complicated function. But the two parameters are, and remind you, this is the number, the size. This tells us what the new size is. We divide the original size in b many equal parts. Very often it's just 2. B is often 2, but doesn't have to be, but it's often 2. This is how many of those smaller problems are we going to carry out? Well, we're going to only do one tournament, right? We do these games, true. So this will be n/2 games that we have to play. But once we have done all these n/2 games, we're going to play one other tournament. So we could say here n/2 plus, this is the number of times we have to put together. We have to do this separately. We have to play this n/2. So the divide and conquer analogy is not always correct in the sense that it is not just first divide, then conquer. Sometimes we have to first do some stuff, then divide, or halfway, something like that. So don't take this analogy too literally. It is reducing it to a game of size half, 1/3, 1/4. That's what the B refers to. And in this case, we refer this tournament of n teams becomes a tournament of n/2 teams. Okay, that is this. How many of these tournaments we're going to have of n/2 teams? Only one tournament. That's the new tournament, right? It's not that we're going to do 2 or 3 of this. But we have to, in order to set this up, we have to do these many steps here. Namely, we have to have n/2 matches with these each of these 2 guys playing. And again, because we need to know the winners of each of these. And this is going to be the players or the teams in our new smaller reduced tournament. Okay, so this would be the recurrence relation, the divide and conquer recurrence relation for number 14. Now, I just wanted to give you an example, see how far you got there, in these applications, I'm not going to ask you to design divide and conquer. It's not fair, really, because many of the divide and conquer algorithms are very smart algorithms that have only been invented. As I said, some of these are very recent, or we only know very recently how to do them. And so it's not fair to expect you to be able to do these things, right? It's not easy. The divide and conquer is one of the more advanced computer science one of the more advanced stages in computer science, where we have to really come up with very smart ideas of dividing a problem in smaller problems. Okay, so this is all for the homeworks. Don't worry too much about it. The main part of the homeworks is really what we do today, and is to be able to to find the complexity of this divide and conquer recurrence relations using the master theorem. That is going to be really the more important thing, and that's what the homework will be about for the next section.